Welcome to this session and welcome to Circular Economy. The goal of this inspiration session, like both Walter and Deepak said, it's not to just give an inspiration session. Our goal of our hope is that this will be the start of a trajectory to really explore what circular economy and more in depth circular ship design could mean for the maritime industry. So I'll start with a keynote, and afterwards you might have seen some tools lying around on the tables behind us. There's this workshop exercise to explore the potential of what circular economy, circular strategies could mean for us, for the industry. But then afterwards, and Deepak will also dive into that more in depth, we have a sort of follow-up track to see what ideas are we going to explore further, how can we support you in actually making it from an idea to a validated business concept, and how do these different concepts then again merge together into a new way of ship design. What could that mean for our industry? But first, the circular economy. This is a projection, a world projection that I really like. It's the Spillhouse projection made in 1942. Basically, what if we do not project our map based on the land that there is, but on the water? Because 70% of our planet is water. There's this saying in English, we should never have called it Earth. And when you talk about sustainability, when you talk about climate change, about our economy, in the end, it all starts and it all ends with the ocean. That's really the spine of it all. And that's why I find it so fascinating to look at circular economy, to look at sustainability from this maritime point of view, and why I think it's so crucial to also have this industry, not just as an industry that is following on circular economy, but maybe even taking the lead and showing how it works and what it could do. Now, before I start into what circular economy is, maybe it's important to first frame why should we even care about circular economy. So I have a little quiz. How much waste does the average person globally produce in one day, do you think? Who thinks it's 0.34 kilograms? No one, right? 790 grams. And then 1 point, right? It's only 790 grams. But that leads to the next question. How many are we on this planet? Who think it's 8 billion people at this point? One person? 2 person? 7 billion? Right? 6 billion? No one? It's 8 point something. But that means that globally, every day we produce about 632,000 tons of domestic waste. That's just domestic waste, right? It's not the biggest waste production there is. And that's in terms of how much stuff we throw away. But then there's also a big point to be made on the effectiveness of how we use our materials. All right. The average use time of a power drill in its entire lifetime, how many minutes or hours do you think that a drill actually drills? Who would go for plus 3 hours? No one? In the average household, if you're really handy, you use it every day, that's another thing. 1.5 hours, all right? Less than 30 minutes? It's less than 30 minutes. So everyone who owns a power drill probably won't use it much more than half an hour in its entire lifetime. Same goes for cars, by the way. How often do you think is an average car used to actually drive with it? 4% of the time? 14? 24? All right, it's 4. And of that 4%, 1.3% of the time is used to find a parking spot or stuck in traffic. So that is something. So not only are we not using our materials efficiently, but we're also not using it really effectively. Oftentimes it's built in a product and then it just sits there, waiting to be used. And we can tell that for every product that we make, including the products that we use in the maritime industry. So when looking at ship design, when looking at vessels, this is very much making it very simple. So the truth is probably a bit more complex. But basically what you have when you make a ship is you've got a big investment cost. You can use it a long time, and you have to make sure that you get your return on investment in that use time. And at the end of time, so you get sort of the use time versus operating cost. The longer you use a vessel, the larger the operating costs come in terms of keeping the thing running. Maybe it's less efficient, whatever it is. And then there is, at the end of the pipeline, there's residual value, which most of the times in ships is scrap at the end of the lifetime. And so the question that Deepak and Walter came to me with this was, how can we use circular principles to maybe redesign these vessels to be used more effectively, more sustainably, longer? What would that look like? And I said, I have no idea, but let's explore. So, circular economy. A circular economy, put bluntly in a nutshell, is an economic system aimed at minimizing waste and closing loops, material loops, as long and as high-end as possible. That means that circular economy is not just a recycling economy. Recycling is one of the strategies in circular economy, and it's one all the way at the end. Before you make something waste, you try to recycle it. But there's tons of strategies before recycling that you can use to actually close loops. So some important aspects there. Economic systems means the circular economy is all about business model innovation. It's all about strategic design. It's not just about choosing materials or designing a product a bit differently. It's really about rethinking how you build your business and how you build your value proposition. Minimizing waste, and for me that's an extremely important one. My background is I'm a designer. Waste is a design error. Waste is a choice of making something unusable at the end of its lifetime, at the end of its product lifetime. So reducing waste is not just about doing less bad, it's really about rethinking how can we do better? How can we do good? How can a product that we can't use in this product anymore maybe be used somewhere else? How can materials be transferred to other places, etc., etc.? That's the closing material loops as well. Know what is in your products, know where it is, at what point, in what quality, and then try to close it as long and as high-end as possible. And for me, when I started working on circular economy, also already I think 15 years ago maybe, I immediately saw these business strategies as an opportunity for innovation and entrepreneurship. Not just about we have to stop doing stuff because we can no longer keep doing them. You can't keep growing and using materials in an infinite, as an infinite resource on a finite world. So you have to find ways to go about that. But it's also an opportunity for building really new and exciting business models, business opportunities, innovation. And so I brought with me some examples of companies that I think are using some of these strategies in really clever ways to build new stuff. I'm assuming that my animations on these slides did not transfer as well, but we'll explore. So the first one I want to talk about is Arrival. Maybe you know it. Arrival is a last mile delivery, bus, truck, package delivery kind of service. And what they do is, instead of building cars, instead of building vehicles that run around in cities, they explore what kind of vehicles does this city need for last mile delivery, for transport, for public transportation, for picking up garbage, whatever it is. And how can we make a micro factory at every single city and then build the kind of vessel that they need. For example, I live in the city of Ghent. In Ghent, we have very specific garbage trucks that can actually pass through Patershol because the streets are very narrow. So they had to build their own garbage truck that can only be used at 5 streets maybe. So what they did is they said, well, if a car can actually be reduced to a battery, which is the floor, and then 4 wheels that have the motor, everything on top of that, you can choose how you build it. And if we make it completely modular, then we can make a last mile delivery truck, and then we turn it into a bus, and then we turn it into garbage truck, and then we turn it into something else. And so they started exploring with how can we make stuff very flexible, even while it's in use, to make sure that it suits whatever this city needs at this point. So instead of just buying your fleet, you buy the service of having public transportation, of having last mile electrified delivery, etc. So Arrival, what they do is they come to a city, build that micro factory, and make sure they service whatever the need at that point is of the company. Recently they launched their first buses and they're actually starting to produce. The next one, maybe one that you know already, it's kind of a circular economy darling, is Power by the Hour by Rolls-Royce. So Rolls-Royce, apart from the cars, also make engines of planes. And what they noticed somewhere late 80s, beginning of the 90s, they noticed that a lot of Asian manufacturers came up with airplane engines that were maybe not as good as theirs, but much, much, much cheaper. And it was a really difficult market to keep, a market share to keep. And so what they said is, well, we can go starting price competing with these people, but in the end it's a race to the bottom. You never win in a price competition unless you can really dive under everybody and you have to cut margins everywhere. So what they said is, what if we start looking into the industry and see what are the biggest pain points of our industry? And in aviation, the biggest cost is the moment that an engine does not work anymore. Ideally when it's on the ground. Most of the times when an airplane lands, they check the engine, they see, does this still work? Is it still good to go for the next flight? And if the answer is no, then there's a problem. Because then, first of all, you need to reroute a lot of people. So a lot of aviation companies have sort of spare planes just waiting for an accident to happen to then get people back to where they need to go. Then an engineer has to be flown over. They have to control the engine, have to check what's the problem, where's the issue, what kind of spare parts do we need. Then they have to find the spare part, have to fly it over, maybe with a mechanic who knows how to install it. And then maybe after about 2-3 weeks, the airplane can be airborne again. And that's 2-3 weeks of standing still somewhere, not being able to use the airplane, and you have an extra spare airplane that's also flying around. So what Rolls-Royce was figuring, well, if the biggest cost is actually not being able to fly, then why can't we sell flying hours instead of flying engines? What if we make the promise that with our engines, you only pay for the hours that you're in the sky, and we promise you that you will not have a damaged engine? So what they did is they put all kinds of sensors in every engine, and they knew at every time what the default was of each engine. When it landed, they knew if it needed revising, if there was a spare part needed, if an engineer was needed, and when that was the case, they made sure that whatever your flight schedule was, that the engineer and the mechanic were there to fix the engine before you had to take off again. Now, this sounds like a very good idea. The truth is, when you build this kind of model, what they had to do is they had to buy back every single engine that they ever sold, because you can't make the promise to have an ever flying engine and then have someone else with an engine of yours that's broken, even though it might be in a different business model. So Rolls-Royce almost went bankrupt buying up all their existing engines. But at this point, they've got, I think these were numbers of 2020, but they got the largest market share at this point in airplane models, because people want to buy for the service of being in the air, and it's much easier to also calculate the costs that your airplanes will have to make sure what your margins are. It's a much easier model to operate as well. So that's the service sizing and designing for longevity. What you start doing when you make these kind of business models is you make sure that your engine is not built to fail. You can also go much smaller, for example, with Miele, the washing machines. What they basically do, you can make a washing machine that runs forever, basically, but that is really not a good market strategy. So what they do is they blame it on cost and quality, but they make sure that the washing drum in the middle at some point gets tilted maybe a little bit and it hits something, who knows what, and it flies around and it hits something else and then it's broken and then you have to start searching. But it's perfectly possible to make a washing machine that doesn't die. But then you have to make sure that you don't sell a washing machine, you sell the service of clean clothes. And that's, for example, what Miele has been doing with social housing projects in the Netherlands since the past 10 years, I think now. Open-ended design, another one of my favorite, both the design strategy and also Little Bits. Little Bits is basically Lego on steroids. So if you have a nerd kit, or you're a nerd yourself, or you want to blame your kids for buying toys, Little Bits is really fun. So what this basically is, open-ended design is basically make sure that whatever the entry point or the end point of your product is, make sure that other people can tap into it, that people can build onto it. So what Little Bits did is they wanted to make a design kit that makes it easier for kids to build stuff, to make robots, to make home automation, to make whatever it is. And so they made sure that the connecting parts between modules are magnets. You can just put them together. There's inputs, there's stuff that you put in between, there's output, and then you can just start building whatever you want to build. And what's interesting there is because they make this, there's an entire community growing around Little Bit saying, oh, well, we would like this kind of kit. We want to make sure that we can make a video doorbell, whatever thing. And people start designing for them. And then they just have to make sure that they build the modules at the end of the day and make sure it's there. Even their entire sales proposition is built around this. Instead of having a store, they basically have this big playground where on a Saturday morning kids can just come in and they can start playing around, and the best invention at the end of the day gets a free prize, and all the other kids start nagging to their parents, and so they also get a prize. But while they are tinkering around, all these kids, they start building new kind of things. They may build a robot and they, oh, maybe we need a robot kit. And so they have, their users are becoming their designers and are becoming the testers at the same time, and they get a constant feedback loop on how this works, how they can make it even better. So, back to our vessels. What if, using circular design principles, we can shift this line here and extend it, make the use time of vessels longer? Maybe we can improve the residual value. What if we use modular design to make sure that we can interact at certain moments with our ship, take stuff out of the ship, put something else in it, make sure the value becomes higher, make sure that the operation cost is lower? What if we can make sure that in an energy transition, when we switch from diesel to electric, whatever, that we can actually make that switch, that the propulsion is not fixed for the next 50 years, but that we can switch around if needed? That's the main question that we are exploring today, and that I would like to invite you to explore, especially today. So how can we increase repairability? What would that mean? What would that look like? What kind of services could be built around that? Is there a possibility to shift from fuel source, especially when we haven't decided yet what the future fuel will be of our vessels? You can't decide on a very specific engine or propulsion. So how are we going to go about that? How can we increase effective use time? How can we create a higher residual waste value? No, not waste. Stuff like that. So, up to you to explore the possibilities. What I would like you to do, so in a minute we've got all these tools around here at the tables. You're going to explore, coming from how you look at the maritime industry, what you are doing, how can we rebuild this model, also what kind of business models come out of this. Maybe some inspiration cases, but feel free to add stuff yourself to this. I really believe in this saying by Picasso, good artists copy, great artists steal. It makes no sense to design everything yourself or rethinking everything on your own if it's already been done. So what you will find on each table is you'll find a card deck. And on the card deck, I think it's about 50 different design business strategies that you can use for circular business design. On the front of the card, you have the strategy. On the back of the card, you've got an inspiration case that uses this. Please steal from this. Oh, but if we would do this and we would combine it with that, then we could do this. That kind of thinking, right? But I also brought 3 cases that maybe look at their industry from another way. One, again, from the aero industry. Aerocircular, maybe you've heard about it, was a Belgian startup. And what they did is they tried to revolutionize the way that we treat end-of-life aircrafts. What if we don't see an aircraft as scrap, as something that costs and you have to sort of get rid of it as fast as possible? But what if we see it as a bank of materials? If we know what's in there, if we can take it out and we can reuse it on specific parts, maybe we can get actually more out of this than we are right now. And if we can then go to the beginning of the design cycle and actually design together with Boeing and Airbus and whatever, and make sure that these planes were made to be taken apart, what can we do with this? So They pioneered an entirely new way of demontaging aircrafts and make sure that the high quality, high grade aircraft materials could be again reused for whatever they were built. And what they did initially, and I think that's important in strategies, they include the entire value chain within what they did. They didn't just position themselves as recyclers of aircrafts. They positioned themselves as, we are going to take apart the aircrafts, we're going to learn what the wear and tear of these aircrafts are, how you can design them better to be used longer, to be used more effectively. We're going to look into all the different materials used, going to make sure they are de-assembled more easily. We're going to set up partnerships because we are not going to do everything by ourselves. One of the things they created, for example, they noticed there's a big, again, nerds are ruling the world right now, a big nerd group who loves to spot airplanes, talk about airplanes, have little airplanes in their offices, all these kind of things. So they figured, what if we could take the engine out of a Boeing and turn it into a coffee table? There are people who really want that in their homes, and it's much more worth than just scrapping it. What if we can use the fabrics or the textile that we use for the buckles, and what if we can turn that into backpacks because it's high grade material? What can we start building for fans of aeroplanes? How can we turn that into merchandise for the brand maybe? And then they started material upcycling as a part of that strategy. Another one, Znaps together with Deme. So I guess we all know Deme, right? So right now what Deme does often, or did very often, is basically they did a calendar-based maintenance of the vessels, of the platforms that they have. So they make sure that we revise everything on a date that is given to make sure everything is at all times operational. And so with Snaps, what they did is they sort of embraced this idea of the Internet of everything. How can we make sure that we, through sensors in combination with observation, how can we make sure that we know what the exact wear and tear of everything is at every single point, and that we only start maintaining stuff when it needs maintaining? That we don't put too much time on just running around exploring whether or not it needs maintaining and stuff like that. So how can we make it more predictive? How can we make it a standard that we can implement it everywhere? And how can we go from building as a material bank, which is a practice that has been used in the construction industry for a while, as in 10 years. Now, how can we transfer that idea to shipping as a material bank and start looking into that? And then lastly, Moray. So Meridia is a Netherlands-based offshore engineering firm, and they are exploring ways of building offshore wind turbines, not rooted in the ground, but floating around. So they made this kind of eel-looking like structure where they can build up a wind turbine. And what's interesting here is, so the design allows for 15 megawatt turbines, but it's made for serial production. It's made out of standardized components, so they can very quickly make the base on which they build the turbines. And so they can make a very costly engineering challenge, which is offshore wind energy, and they can turn it into something that is much more flexible. You can move it around, you can change it around if needed, and you can focus on simplicity, and you can make sure that the transport of everything is much more efficiently because you only have to transport standardized components around. So 3 different cases that are really rethinking their industry again. What I would like you to do now is go sit together in groups of 2 times 2 and then 1 times 3. Share a bit your insights, your thoughts. Why are you here? What are you looking into? How are you looking at circular economy? What is your link with the maritime industry? Explore that a bit. Then you'll notice, I'll just quickly run there and grab one. You will notice these card decks on the tables. So feel free to browse around in there as well. Maybe divide it up in 2 so everybody looks at half of it. Might go faster. So what you see is basically these have different sort of big strategies: rethinking materials, there's product redesign, smart production, we have distribution, use phase, looking at collecting, looking at partnerships, pricing models, and then bigger overarching sustainability mindsets, all with strategies that you can use, residual value and exploiting that, but also looking at repackaging, for example, Oho Notpla, who were recently in use for their seaweed-based materials. How can we start looking at that? And I think that's important when exploring. We'll do an exercise called X plus Y equals Z. Basically, what are some of the insights, some of the challenges that we're trying to focus on, look at? What are things that we want to get our hands dirty on? What are some of the strategies that we think are interesting and why? And not just, can we copy what this case does? That's the easy way, it's rarely the case. But why is it smart? What did they do that was different from what I am used to see? What did they do that was interesting? And what if we would do that? What would that look like? How would that translate to our case? And then try to combine those two. What if we use this strategy to solve this specific problem? Then maybe we could build this kind of business innovation. Whether it's product innovation or a business strategy, it's always a combination of everything, right? So fill in the blanks on the paper, and then we'll go around and see if everybody made their homework, so make sure that you do something. So basically, what are the top insights from the inspiration cases that you take, or from your own ideas that you take to this workshop? What are 3 strategies that you feel would be interesting to put in a combination together? And then lastly, well, give it a name. Every good concept needs a name. But what is the idea? What is the concept? Why is it smart? And then how will it affect that curve? Will it make the use time of vessels longer? Will it make it more adaptable? Will it increase the residual value? What will it do? How will it impact the vessels or the maritime industry in a broader sense? So that's the objective now. So go ahead, pick a table, grab a friend, and build something. I heard from the table there, we're done, we've saved the maritime industry, so that's a good start. What's important when you start pitching ideas is to know that all ideas grow out of other ideas. There's no such thing as inventing stuff. It's more reshuffling ideas that already exist in a different context. So whoever wants to go first probably has the most original idea, because everyone else will have parts of it and add stuff to that. So the good thing is, if you go first, you can claim expertise. If you go second, you can say, yeah, we had the same idea, but better. And you can sort of make it bigger. Whatever works, works. But we've got 3 groups, so I would like to invite the first person who wants to pitch their idea up front. And I see you are very anxious to go here, so I'll let you do it.
So thank you. So what we see today is that a ship has about a lifespan of about 30, 40 years, something like that. But not everything on a ship has this lifespan. You have, for example, propulsion, which can last 30 years, but what we see is that technologies change so rapidly that after maybe 10 years, there would be another one that would be more suitable. Same thing for navigation, same thing for example, lightning, etc. So if you put all these kind of technologies into a service, if you recommend it as a service, and build it in a modular way, you could actually increase the lifespan of certain parts of the ship, for example, the hull, and the hull is not penalized by the lifespan of other technologies on board. So besides that, which is also an important part, is that we start looking at the ships as a material bank, that we put when you build a ship, you have a certain tonnage of materials on board, but at the end of the lifespan of a ship, you maybe get a fraction of what these materials once were worth. But as we all know, Earth is finite, so all materials that you use, you have to take care of them, and at the end of the lifespan, they also still have this value. For example, steel you buy today, tomorrow it will probably be worth more. So that was the second part of our idea. So I hope it's a little bit clear. I don't know if it's good enough.
Absolutely, yeah.
Or if you need some more explanation. Any
questions
or
you have? What I think is interesting is this redefinition of a ship being a cost to it being an investment.
Absolutely. So you make at the beginning of at the building of the ship, building of the hull, you make an investment in materials, namely. But at the end of this life, you're sure that this investment will be paid back because, well, the scarcity of materials will make that, of course, the value goes up.
Mm-hmm. And what the thing I forgot the car company's name. So anyone who knows it while I talk, please shout. There's a car manufacturer that looked at households and said, well, the first biggest investment of most households is a house. The second biggest cost is the car. The thing is, a house, when you sell it, is worth often more than when you bought it. A car just is a cost.
Yeah.
So you have to get rid of it at some point. And so what they figured is, what if we treat it as the biggest investment that you do apart from the house? And we build an entire service around it that you can, when you buy a car from us, you put it in a bigger fleet of cars in your city. We'll calculate the return on investment. When people start using it, you can unlock it using our app, and people can start driving around with your car in our city. You've all seen it driving around because it's also in Belgium, but I just can't find the name right now. Link & Co. Okay. That's the one. They look ugly, but they are a really cool business model. Thank you very much. All right, next up, a similar idea, completely different idea. Don't fight for the place.
Touch points.
Touch points, perfect.
I have a bit of problem still with structuring the complete story.
Right.
We were toying with the ideas of the fact that ships, they serve a certain purpose, and after a while they do not serve that purpose anymore. They're built very sturdy, but after a while they're not fit enough anymore for the Atlantic Ocean or the North Sea, and then they sometimes put it to more quiet waters. That's a way of thinking about it, to start building very sturdy ships, use them there, and then move them somewhere else. So in the end, ideas were to use ships as floating harbor terminals, to use them as flood-safe spaces to put stuff on if you're in a risky environment. But in the end, the main idea was that right now there's a lot of uncertainty about the energy carrier for ships. So people now building ships are having the risk of, well, will it be ammonia? That will be the next big thing. Will it be hydrogen? Will it be methanol? We don't know. And so if you build a ship for some purpose, then it may be that after 10 years it's completely outdated because the fuel of the moment is something else. So you want to build a ship with a modular propulsion system that is easy accessible, so that you can switch it once you see that a certain fuel or energy carrier is winning, say. And that's, I think, the best that we came up with. And something else that we were toying with is, what if we're 3 shipping companies and we don't want to carry the complete risk of what will be the next fuel carrier, energy carrier, that we make a new company that provides thrusting power for us, and they carry the risk. They are the ones who fit the ships with modular engines. They are the ones that can broker big ammonia or whatever deals, and they take care of, they worry about what will be the next fuel, and whatever happens, they can share the risk among all those shipping companies.
Cool.
So modular design.
Cool. And I think also important is what we see when we talk about energy transition is people often talk about what it is right now. I've got a mic right here. People often talk about what the energy source is right now, and then they talk about what it is after the transition. And then there's sort of a vacuum in between where something has to happen, but nobody makes it happen. I think it's interesting to sort of play on that moment and see how can we be servicizing the transition in and of itself. And then one of the discussions that we had, Deepak, when we were talking about energy transition is the role of the ports in all that, because the ports is where you basically tank your fuel. but it doesn't have to be that way, right? During the Cold War, planes were being tanked while they were flying because they had to be in the air all the time. So maybe if you're servicing the fuel side and you might enter a port that might not have whatever fuel you're going on, maybe you can have a fuel boat just laying outside of it to continue the journey. Interesting idea. Last one?
Yes. We took the inspiration mainly from the Rolls-Royce engine case study, whereby you switch from a product to a service. I think it's a nice solution for both the airline operator and then, let's say, the engine manufacturer to really build a good engine which has a very long lifetime. Now, in that case, the engine manufacturer could still build like a really gas guzzling engine, so completely inefficient, an environmental engine, because he has no real incentive to build something which is environmental friendly, so less emissions. So the fuel expenditure would be lower, but also the greenhouse gas emissions. We translated that, of course, to the maritime environment, whereby we want to start the concept of paying for transport work. So instead of an owner buying an engine, putting it, buying fuel, sailing around on a spot, paying for the fuel, maybe there is an option that engine manufacturers offer, let's say €1 per ton mile transport work, whereby they need to follow the greenhouse gas IMO strategies and hence also need to build, let's say, a fuel efficient engine. So we want to put the fuel efficiency and the fuel usage also into that equation, because we see that a longer lifetime but also a more environmental friendly engine would be a better solution to all.
Cool. Thank you very much. And I think again it aligns very much and very well with the service sizing strategy that we often see in circular economy. When you start offering products as a service, one of the main things, one of the key principles in the business model is aligning the incentives of the efficiency and the effectiveness of the product with the service that you're offering. For example, Philips has this paper Lux where you pay for light rather than for lamps. One of the things that they had to make sure is that their lamps don't fail too often, because the biggest cost in their business model is servicing and maintaining. So if they can track what lamps are on and what are not, they can make sure that the lamps are repairable, that they can extract the materials from it again. And even, for example, in Schiphol, where they implement as well, it's not just the lamps, it's also the energy usage is their risk. So Philips made lamps that are very efficiently, and they made sure that they put solar panels on the roof and batteries to make sure that they could counter that, so they didn't have to pay for the volatility of the price of whoever serviced the energy there. And I think that's a very interesting way of looking at it. The bridge of Millau is the same idea, right? It's a partnership that built a bridge to cover sort of the valley in Millau. And it's a toll bridge, basically, so you have to pay to pass. And the idea was that the consortium that has the winning idea can build it for the municipality, and you can also charge the toll. And you can have that for 30 years, the moment they can charge the toll. And what you have to make sure as a party who subscribed to the tender is you have to make sure that in 30 years you get back the cost of building the bridge, plus ideally some extra. And the moment that sort of the 30 year starts is the moment that we say that you can build the bridge. So basically what they did is they had to make sure that they could build it very rapidly with new technologies to make sure that it was there quickly, but also that it was sturdy enough to not need service for 30 years. And when you're building something that doesn't need that much service for 30 years, it'll probably last 50 years as well. And so that's a really interesting way of looking at service sizing, is make sure that the incentives are aligned with the people who offer the service. And then it works oftentimes. It's very much about knowing not just what the product is, but knowing why the product is there, what it's actually solving. And that's a question that a lot of companies venturing into circular economy, that's very often the very first question is, why are we here? What exactly is the relevance of what we do? What are the tools that we use to make sure that we can provide this? And how can we, instead of selling lamps, start selling light? Because people don't want lamps, people just want the room to be light. unless you make design lamps, then it's the object that you might want. And then it's maybe making a room put together nicely. Maybe that's more your service that you're offering. And how does that work then? So very interesting. And also servicing much easier in B2B than in B2C context. Because in a B2B context, it also means predictability. Subscription fees are predictable. You know what the cost will be, you know when it will arrive, you know how it will arrive, and you can start building upon that as well. Same goes for banks. They are much more eager, especially since COVID, to look at service models and seeing how can we support that. Because it's much more predictable than relying on price volatility, scarcity of resources, stuff like that. But then again, if you use your vessel as a resource of a bank of resources, then it's an investment again that you can start using. Thank you very much for the first ideas. In Dutch we would say this is een vingeroefening. So first test, a first try out with some strategies. There are tons and tons of different models that you could explore with circular economy. And that's exactly, if Deepak moves his arm out of the way, what we would like to do with this. No, it doesn't move anymore. Anyway, that's exactly what we want to do, and Deepak is going to tell you what's next.
Inspiration is basically step one. Okay, I think there's tons of inspiration. Everybody does inspiration, but that's not where it ends. That's where it starts for us. What we're looking to do is build coalitions to say, hey, here's a good idea. Here's something that I, as an individual, company, or a person, would not be able to solve, but I can find other people here that can help me build on this idea, and together we can do something. And then venture into action to actually say, let's build something and let's actually get things moving. So what are the next steps? We're building a trajectory. So there is a course by Jan on Circular Innovation Manager that actually helps you build new circular business models and figure out how to go about actually designing something that is going to be from the ground up circular, which is a super interesting course. But the idea here is to actually come back, do this course, and pitch to a coalition of ship owners and investors to start looking at what's the impact going to be? What is the solution space? What can we do? What are the crazy ideas that we can do to actually create circular ship design? So you can apply your crazy idea by the 15th of December of this year. We, dependent on how many applications, will get definitely back to you before Christmas. Then the course starts the 15th of January. You'll get a mail from us and a mail from Jan saying, congratulations, come in, join the course. And then the 15th of March, you come and pitch your idea. You work it, you go through the course, you fine tune your idea, and you come and pitch this. For who is this? This is for anybody who has a good idea on any means to increase the circularity of ships in the maritime. So if it's increasing the lifespan, if it is modularity, if it is finding a way of lowering the cost of propulsed ships, as a service models, recyclable models, whatever. I mean, you come up with the idea. It could be part of a solution. It doesn't need to be the full solution. But whatever it is, we want to see what the solution space is in this domain. And we want to inspire the maritime industry to actually say, well, here's some very valid and very interesting ideas to move this thing forward. So we'll send out a mail to all of you participating here. Again, if you know people who might be interested or might have a key to the puzzle here, do share. I mean, we'll put this video online, so do share this video with them so that they can also kind of get inspired and help you. I mean, the more pitches, the merrier. And again, it's not about having this one brilliant idea. It's about having a million ideas and then gluing them all together to this one solution that we could use. Thank you.